Chapter 9, Measures of Dispersions, Section 9.1, Introduction. In Form 3, we have learned three measures to describe the central tendency of a set of data. They are mean, median, mode, or model class. They are useful if we want to study the central tendency of a set of data. However, apart from this measure, if we want to study or have some more information about the distributions of the set of data, we need some more measurements. And in this chapter, we will learn three measures of dispersions. Let's go ahead to study what they are. Okay, here we have a warm-up activity. It is amended from activity 9.1. In an archery training exercise set in front knee, the scores obtained by two athletes after 7 shots are as follows. That means the total number of data is 7. And we have two sets of data from athlete A and athlete B. Now, question 1, we have to complete the table. We have to find the mean, median, and mode for athletes A and B respectively. Here, if we want to find the mean, okay, we just find the sum of scores of each athlete and divide by the number of data. So after pressing your calculator, you can find the mean is 7.5 for each athlete. And for median, the middle, that's like the datum that's lie in the middle of the data. Here we have the ungrouped data, and there are 7 data. That means it is of odd number. So when you arrange or rank the data in ascending order, the fourth one will be the median. So for athlete A, the median is 7.5. And for athlete B, it is the same. And third, when you want to find the mode of each athlete, you are finding the datum with the highest frequency. And for this case, you see that 7.5 is the datum with the highest frequency for each athlete. So the mode for both athlete A and athlete B are 7.5. So here, from this finding the table, we found that all the measures of central tendency are the same. So can you say which one performed better? Of course, if you only study the central tendency, the 3 measures, they are all the same, so you can just conclude they perform equally well. So we just say, because the measures of central tendency for athletes A and B are all the same. So we conclude they perform, refer to the questions, equally well. Now, let's study the distribution of score by using a special diagram called dot plots. Here, you can just plot the data on the number line with a dot. Say the data 6, 6.5, 7, 7.5, 8.5, 9.5. So for each athlete, we can have a dot plot, and we can view the distribution of the set of data of the scores. We found that for athlete A, the distribution of data is like that. And for athlete B, you find the distribution is like that. So from the dot plots, can you conclude if we want a more stable athletes to be selected for upcoming events, who will be selected? From the dots plot, we observe that the score of athletes A are more spread out, 分散一啲. So here we can say that athletes B, the performance is more stable as the distribution of the score are more concentrated. We will say the data sets are more concentrated, 集中, spread out, 分散. So, for question 4, if you were the coach, which athlete would you select to participate in a competition if you only count the suits with the highest score? Which one will you choose, A or B? Here you can see that for athlete A, he or she can achieve a higher score, so athlete A should be selected. If for part B, if we concerned the total score of all the suits, then we would like to select an athlete with a more stable performance. So we will select athlete B. So from the warm-up activity, the two different sets of data, they have the same measure of central tendency, but they may be spread out quite differently. In fact, apart from the measure of central tendency, we would like to also study how dispersed or how spread out the data are, and we need some more measures. We will say the measures are measure of dispersions. We will learn range, interquartile range, and standard deviation in the following or coming sections. Section 9.2, Range and Interquartile Range. First, we will study the first measures of dispersion called range. Okay, this term in statistics has a different meaning from what you learned in your daily life or in previous mathematics lesson. Here we have a special meaning in statistics. For range, if we want to find the range for the case 1, ungroup data, then just very easy. Just find the largest datum and then subtract the smallest datum. Say, in the activity we already studied, whose score are more dispersed? Then, from the 7 data of each athlete, you find that for athlete A, the largest datum is 9.5 and the smallest is 6.0. So we have 9.5 minus 6.0, so we got 3.5. And then for B, the highest datum, the largest, is 8.0, and the smallest is 7.0. So the answer is 1. So by comparing the range of each athlete, we found that the range of the scores of A is greater than that of B. So when the range is greater, we will say the score of A. The score of A, this data set, is more dispersed. So when the range is larger, this implies the data set is more dispersed or more spread out. 分散啲 data 分佈。And so we learned some key terms to help you to answer some questions. We can say the data set with higher range is more dispersed or less concentrated about the mean, mode, or median. Or conversely, we can say the data sets with a smaller or lower range, the distribution is less dispersed or more concentrated. Let's try a simple example. Quick practice 9.1. The following shows the prices of two brands of sports shoes in a shop. There are two brands A and B, and the prices are as follows. Now, for part A, you are asked to find the range of the prices of each brands. So, just for this ungrouped data, we look for the highest datum and the smallest or lowest datum. For brand A, the highest is 780 and the smallest datum is 250. So for A, you can write for brand A, the range equal 780 minus 250. So this is 530. For B, please pay attention that the data are not arranged in ascending order. So here, the smallest is 280 and the largest datum is 600. So for brand B, the range is 600 minus 280, and so the answer is 320. Now for part B, it is a simple explain your answer questions. Which brand has more dispersed prices? So you look for the one with higher range or larger range. So should be brand A. You just write because the range of the prices for brand A is greater than the range of prices for brand B. So we can conclude brand A. The prices of brand A are more dispersed. Because the range is greater. Case 2. For grouped data, we can find the range by finding the highest class boundaries minus the lowest class boundary. Let's study one example. Here we have a table showing the weights in kg of 24 basketball team members. There are 24 data, and now we have to first organize the data. For these 24 data, we can put them into 4 class intervals. And we count the total number of data for each class interval. We put or organize the data by using the frequency distribution table. And we count the total and we count the number of data for each class interval. That means we found the frequency. So for each case, say for the first class interval from 41 to 50 kg, there are 5 data. And then for the next class interval, 51 to 60 kg, we have 10 data. And for the third class interval, we have 5 data. And for the last one, we have 4 data. You can check here. The sum of them are 24, so you count correctly. And then for each case, we have to find the class boundaries in order to find the range. So we try to write for the first class interval, the datum between 50 and 51 is 51.5. And for the next class boundary, we have 60.5. So similarly, you can fill the remaining. And for the lowest class boundary should be 40.5. So here, we try to find the highest class boundary should be 80.1. And the lowest class boundary should be 40.1. So for this group data, we can find the range by 80.5 minus 40.5, and we got 40 kg. This is the answer for this case. Now, ask you one question. If the largest datum change from 75.7 kg, this one, to 79 kg, how will the range of the weight change? What is the new range? I give you 3 seconds to think. 3, 2, 1. Here, because 79 still 9 in the 4th class interval. So the upper class boundary 80.5 is unchanged. So there is no change in the range. Still, we have 40 kg. For both case 1 and case 2, ungrouped or grouped data, you find that the range, the calculation is quite simple. Just do some subtractions and find the difference. And so you just go ahead to try quick practice 9.2 and do on your notebook. Now, let's think further. If I give you another set of data, 1, 2, 3, 4, and 50. For this set of 5 data, what is the range? Okay, first, this is ungrouped data. That means case 1. So you just find the highest datum, the largest, minus the smallest. So we have 50 minus 1, you got 49. And actually, in describing the dispersions of a set of data, we can use range as one measure to study how spread out or how dispersed the dataset is. And the advantage of using range, of course, you experience already. It is easy or simplest to calculate. However, when you study the set of data, you find that actually 4 of the 5 data are quite concentrated around 2.5, and only 1 data 50, which is far away from the 4 data. And you find for this case the range is 49. It is quite large, but actually the values of the range is affected by this very large data in this data set. So we can say the disadvantage of using range as a measure of dispersion is that the range is easily affected by, I know you remember the terms, by extreme data, 一啲好大或者好細嘅數據。Now it's your turn. Try the daily exercise. Some questions in exercise 9A. Question 2, 3, 4 are level 1 questions, and 14 and 15 are level 2, but all of them are quite easy to calculate. Just one thing, you have to revise histogram and frequency curve. If you have any problems, you can ask me or watch the videos that I send through the Google Classroom. The videos can help you to revise the knowledge, the diagram you have learned in junior form. Okay, this is the end of this lesson.